Potassium permanganate is a very strong oxidizer, which means it tends to be reduced rather easily. As you can see, the resulting manganese dioxide stains glass storage bottles. These two solutions are no longer the concentrations shown on the label, and they're heavily contaminated with manganese dioxide. I decided to let the water evaporate off of these solutions and then do something fun with the contaminated permanganate once it was dry. I didn't bother calculating the planned recovery yield because all the contamination would just skew the results anyway. But there's plenty of purple color left, so there should be enough permanganate to burn something. This crystallizing dish can hold about 620 milliliters, so both of the partial bottles should fit in here just fine. Admire its beauty now, because it's never going to look this good again. I have the dish set up in a corner of the lab that won't be bothered for as long as it's going to take to evaporate. I'll start with the fuller bottle, which happens to be the less concentrated. At 0.01 molar, it isn't concentrated at all, but it's intensely purple. The purple color of the permanganate ion is perceptible to the unaided human eye in concentrations as ridiculously low as 0.01 millimoles, and perhaps even lower. Once both bottles were in there, there was a little room to spare, and for reasons I can't explain, I ended up adding a little extra water. I left a little liquid in the bottom of the older and more concentrated bottle because I figured the majority of the manganese dioxide would have settled out. I used two inverted 150 milliliter beakers to raise up a large watch glass over the dish. I figured this would help to prevent dust getting in there while still allowing water to evaporate easily. And through the magic of editing, here we are a month later. There is a good amount of reasonably clean looking potassium permanganate that gathered near the top of the dish, but there's an awful lot of manganese dioxide and other junk in there too. I managed to take a few good still photos of the situation. There were some really nice effects. Mostly these effects are due to contamination, so while it's pretty to look at, it's also pretty useless for anything important. But it's definitely worth taking a few moments to appreciate the purple manganese 7, the green manganese 6, blue manganese 5, and brown manganese 4 all coexisting beautifully in the same sample. Now comes the fun of trying to recover the permanganate and leave as much of the junk behind as possible. I really had to think about it for a while because scraping was the best thing I could think of right off the bat. I was a bit worried though because that was going to scratch the heck out of the crystallizing dish too. I decided to go with scraping anyway, and since I'm not going to use it for anything but a quick demonstration of its oxidizing power, I'm scraping it directly onto a little tin can lid. It was far more difficult than I had anticipated, and I was at this for far longer than I wanted to be. The permanganate, and especially the manganese dioxide, were holding on to the glass with unparalleled tenacity. I ended up not recovering all the permanganate, but enough to burn some glycerin. Before we get to that though, I'd like to share a helpful cleanup tip. This is the poor little crystallizing dish after the initial scraping and washing with running water for quite a while. There was some scrubbing, but I didn't use detergent yet. The manganese dioxide stains are really hard to get off the glass. Let me show you how I did it. This procedure requires really good ventilation, so keep that in mind. First in, about half the dish's capacity of half-strength hydrochloric acid. This is a 6 molar solution that was made from the 10.3 molar hardware store muriatic acid. Next, I filled to near the dish's capacity with 3% hydrogen peroxide. And watch how easily this stain simply vanishes. With gloves, slosh it around a bit and scrub the residual stains with the solution. Make sure to flush the solution down with lots of excess water. I left the water run for about 15 to 20 minutes after I was done. Here's the dish after another 15 minutes of scrubbing with Alkanox. These scratch marks or etch marks, whatever they may be, are never going away, but the dish should still be perfectly usable in the future. Okay, back to the fun part. This is how much seriously impure permanganate I was able to recover. All I'm going to do with it is add about 2 gloopy milliliters of glycerin, and I should get the expected reaction. Oh look, more manganese dioxide. Well, at least that was more fun than just dumping it all down the drain. And on that note, I should say that potassium permanganate is used in the water treatment process in this area, so it would be fine to drain dispose of it here. In other locations, though, manganese is considered a hazardous waste. Be sure to check your local regulations if you have potassium permanganate or other manganese salts needing disposal. In any case, thanks a lot for watching, and I'll see you next time.